Okay, so we want to compute a line integral of this vector field. Here the vector field f is xy and c is the line segment going from 5, 5 to 5, 7. There's a number of ways to do this problem, but since the thing that I want to emphasize here is using the fundamental theorem of line integrals, that's what I'm going to do. So first, notice that if we call this component little f, or actually let me call it little g, and if we call this component little h, then the derivative of g with respect to y is equal to 1, and the derivative of the derivative of g with respect to y is equal to 0, and the derivative of h with respect to x is also equal to 0. And so this tells us that there is some function little f such that the gradient of f is equal to big F. Now you might already know what it is, but let's pretend that you don't know what it is and go through the procedures of finding it. So the way we do that is we first say that f of xy is going to be the antiderivative of g plus some function of y. The antiderivative of g is x squared over 2 plus some unknown function of y that I'm going to call phi of y. Now we know that the partial derivative of f with respect to y is equal to h. Remember, h is the partial derivative of f with respect to y, and g is a partial derivative of f with respect to x. So the partial derivative of f with respect to y is equal to y. But we also know that this expression here is also equal to f. So the derivative of that with respect to y is just phi prime of y. So in other words, we know phi prime of y is equal to y. So in other words, phi of y is equal to y squared over 2 plus some arbitrary constant. And therefore, f of xy is equal to x squared over 2 plus y squared over 2 plus an arbitrary constant. But remember, the easiest thing is just to take that constant equal to 0. And so that's what we're going to do. Okay, so now we want to compute the line integral of big F on the line segment from 5, 5 to 5, 7. A potential for big F is little f, so this means that that line integral is just going to be little f of 5, 7 minus little f of 5, 5. Okay, if we evaluate little f at 5, 7, we get 25 over 2 plus 49 over 2, and then we subtract little f of 5, 5. So that's minus 25 over 2 plus 25 over 2. The 25 over 2's cancel, so we have 49 over 2 minus 25 over 2, and that is 44 over 2, which is equal to 22. Okay, I'm pretty sure going from that step to that step is correct, and I did the subtraction correctly. No, I didn't, did I? 49 minus 25 is 24. 24 divided by 2 is 12. Okay, so that's it. This is the rundown of doing this problem using the fundamental theorem of line integrals.